That'd be so cool.
This is on review worksheet 3, problem number 4. This is a PVA problem and it's using a calculator. It's a little different from what we've done in the past because in this one you are given a velocity function rather than a velocity graph. And what I want to start on is let's just talk about your calculator. So when you are given a velocity function, you want to start by entering that velocity function into your calculator. Before we begin though, once you turn your calculator on, if there's anything in there, just clear it out. Go ahead and hit the y equals window. The class set of calculators that we are using, if you're using one from my bin, also gets used by my AM/DM classes, and they're doing a ton of statistics. So if you see any of the plots highlighted, just arrow up to it and hit enter and then arrow back down and that'll turn it off. You don't want stat plots on for this. Okay, everyone got them turned off? Good. Go ahead and enter your velocity function in.
Should we put it in radians first?
Well, we're going to talk about that too. Yes. Go ahead and enter it in though first and then we'll talk. Okay, so we have 4 sine. It's written in terms of t, but we're just going to use x squared minus 2x plus 2. All right, everyone have the function entered in. Make sure your calculator is in radians. This is especially important for students who take physics, so you hit mode and make sure that the radians is highlighted, not degrees. Before we graph, we're going to set our window. So if you look at the problem, this problem says the object is moving along a horizontal line in meters per second from 0 to 4. These are t values, from t equals 0 to t equals 4. I personally would ignore the hint. And I always set my window with these as my x value endpoints so that I don't accidentally think there are more zeros or less zeros than there actually are. So if you're given a window from 0 to 4, what you want to do is hit window on your calculator and then put your x min at 0 and your x max at 4. Standard window for y's is negative 10 to 10. So we can start there, and then if we need to adjust, we can. All right. Once you've got that, go ahead and hit graph.
Wow.
So this is the graph of our velocity function. Now you're kind of where you were the other day when you were given the graph of the velocity. Here you go. You've got the graph of the velocity, right? Except everything's going to be with decimal, so we're going to have to learn how to use the calculator to find everything. So part A says find the time when the object is motionless. How do we know when an object is at rest?
When
the velocity is 0. So we need to find these 3 spots where the velocity is 0. Does anyone know how we find zeros?
Calculate.
Calculate, so we go second trace, gets us to our calc menu, and then we pick the 0. There are 3 zeros, and the calculator needs to be told which one to pick. If I know this 0 is between between 2 and 3, my left bound, I can just hit the 2 and hit the 3 for my right, like hit 2 for left and 3 for right, and then just enter on guess, and it'll give it to me. Otherwise, you can also just move this little spider guy back and forth until he's to the left of your 0 and to the right of your 0. So my first 0 is 2.463. How many decimals should we always round to? 3 decimals. So our t, 2.463. And of course, if there's a because statement for this, if it said y, it would be because v of t equals 0. Let's find the other 2. Everyone take a second and find the other 2. Alright, did y'all get those answers? Any questions on how to find zeros? Are all comfortable? Yes? Okay, good. Moving on. When does the object change directions between 0 and 4? Well, how do you know when an object changes direction?
When the slope changes.
Okay, when, it depends on the slope of what we're talking about. More specifically, when the velocity,
Positive, negative.
or negative, positive, right, changes sign. When the velocity changes sign. Because remember, the sign of the velocity determines the direction. If it's positive, it's going to the right. If it's negative, it's going to the left. So whenever the velocity changes sign, the particle is changing direction, right? So if we were to look at our graph, the velocity is positive, negative, positive, negative. Where is it changing sign?
The same points.
At those exact same points that we just found, right? So what you can do for this one is say, changes direction at t equals 2.463, 3.299, and 3.903, because the velocity changes sign at those 3 points. All right, now we need the velocity at 3. Easiest, quickest way to find the value of a function when you're sitting on the graph window is to just use trace. So here's our graph. If we hit the trace button, right, so there's trace, hit trace, and then just hit where you want to trace at. We want it at x equals 3, so just hit 3. So v of 3 is negative 3.836, rounded. Are you guys all with me? Any questions? Everyone good? Feel free to yell out if you need. Okay, so negative 3.836. So v of 3 is around negative 3.836. This did not ask for units, but if it did ask for units, what would the units be?
Meters per second.
Meters per second, right? All right, now we want the acceleration at t equals 3. How does acceleration relate to velocity? It's the derivative, right? So we need the derivative at 3. Does anyone remember how to find a derivative on your calculator? Second trace, which takes you to your calculate menu.
Second dy dx.
And then you pick dy dx.
That is so convenient.
And then we want the derivative at 3, so hit the number 3 and enter. Because it's got to be correct to the thousandths, right? So make sure you actually find it at 3.
I'll never do that.
4.539 roughly. What would the units be for acceleration?
Meters per second squared.
Meters per second squared. So, without doing any calculator work now, this is our velocity, this is our acceleration. Is the speed increasing or decreasing at t equals 3?
Decreasing because v of t is less than 0 and a of t is greater than 0.
Beautiful. Yes, it's decreasing. So speed is decreasing at t equals 3 because v of 3 and a of 3 have opposite signs. Does that make sense? Everyone okay with that?
Yes, sir.
Awesome. All right, displacement. Show integral notation. The displacement is equal to the indefinite integral of the velocity. So we need the definite integral from 0 to 4 of the velocity. Are you ready?
Not yet.
Okay.
I was suspenseful.
No,
Drinking the coffee.
Oh. That's why I do it. for this suspense factor. All right. Are we ready now?
Mm-hmm.
Okay, good. All right. So here we go. We have our graph. So to find the derivative, you go to the calc menu, right? How do you think we're going to find the integral?
Calc menu.
Calc menu. So you go second, trace. Which one do you think we would use for integral?
7.
Number 7. So we go down to number 7. It wants a lower limit. What would the lower limit be?
0.
And what would the upper limit be? 4.
Ooh.
Oh, isn't that nice?
It's like that part of Lord of the Rings where the green army comes and just like.
It's just like that.
It's just like that.
Yep. Yep, that's exactly what I thought of. Alright.
Wait, did you do indefinite?
You can't, the 84 can't do an
Where
indefinite.
was this like a week
It can
ago?
only do numeric.
Like everywhere.
So, same thing with derivatives. It can't do a general derivative. It can only do numeric.
It was a while ago.
Your calculator, guys, the question was, can the calculator do an indefinite integral? The 89s can. If you have a TI-89, you can do an indefinite integral. You can get a general derivative. It'll give you the answer that's a function. But an 84 can only handle numeric stuff. So it will give you f prime of 6, but it won't give you f prime of x, right? Same thing with the integral. It'll give you the integral from 0 to 4, but it won't give you the general antiderivative.
So, could a TI-89 also do like the second fundamental?
The TI-89 can't do SFTC because it won't accept, if it's going to do a definite integral, it won't accept non-numeric limits.
Okay.
So that is an issue for the 89. But it can do almost everything else. So, anyway,
It's gonna be the next step.
okay.
So that could SFTC.
So everyone got their displacement? So displacement, integral of velocity, just plug it in.
That is so cool.
Okay, now we need the distance. So remember, this is our graph for
How do we
the
unshade it?
you have to, either have to change the graph or clear the graph and then re-graph. But we are going to in just a second. Okay. You know what's nice, another thing about the 89,
Yeah.
is if you have to do an integral and then say you had to do a separate integral, it will do different types of shading. Like the first time it'll do like straight vertical lines, and then it'll do like diagonals or horizontals, and you can see the overlap of what you're doing. It's really cool.
Why don't they just require us to buy that one instead of this one?
Because those are really expensive.
Oh, that makes sense.
How much more are they?
Okay. I think they're $150. I bought mine used for $100, but that was 10 years ago. So, and more than that. That was like 14 years ago.
Use the Inspire.
14 years ago. But you know what? Even the Inspire, I don't think can do what the 89 can do.
And why is the Inspire like marketed higher than the
Because it has that internet access and all that kind of stuff,
That's
right?
just silly.
Yeah.
They take away things and they.
So, anyway. Alright, so this is displacement. If you guys remember when we did it, when you were given the graph, positives stayed positives, negatives stayed negatives, right? So remember, like if this was like 10, you do 10 minus 3 plus 2 minus 1, that kind of a thing, right, to find your displacement. Distance, you need everything to be positive to add them all together, right? Okay, so distance is the integral of the absolute value of velocity. So for this, I'm going to write my distance is the integral from 0 to 4 of the absolute value of velocity. So to put the velocity function into an absolute value, and it depends on what kind of a setup you have on your calculator. Mine's just a straight old 84. So the way that I have to do it is if I want to put an absolute value around this function, I start by turning on my insert. So I'm going to hit second delete, and now if you do that, your 4 should be blinking, right? It's ready to insert in front of the 4. And then to get absolute value, you hit the math button. It's the third one down on the left. And then arrow over to num. and the top choice is abs. Okay, so math, number, absolute value.
Bouncing ball.
And then I personally, I always like to close my parentheses.
How did you get to go around the?
Do you have one of the pretty prints where it's trying to put the bars?
Yeah.
Then you gotta retype. Sorry.
Can't you turn that mode off on those
You
computers?
can, I'm not familiar
Do
with
you
it.
want to enlighten me, Gavin?
You just go to mode and then you turn off the math thread.
Oh, there you go.
One day it's on math print. Oh,
Okay.
I got it. Thank you.
Alright, so now if you graph, it's the exact same graph, except everything that was below the x-axis is now bounced up, right? So now if we do our integral, from 0 to 4, this will give us the entire distance. It'll take a little longer. Alright, so he traveled around 12.178. Oh, what's this measured in?
Meters.
Meters, right? Same thing for displacement, meters. And if you forget which one is which, just remember distance will always be greater than or equal to displacement. The distance is the full amount you traveled, so if you run them both, the bigger number is always your distance, right? If you get them confused. Okay, moving on right along. Okay, if we have to, this is not on your test, but to find the time when the object reaches minimum velocity, if you're not required to justify at all, I'm going to go back to my y equals, I'm going to take the absolute value off. And this is my velocity. If I want the minimum value, you can actually go to your calculate menu and pick minimum. Oh, oops, sorry, I gotta reduce. It's finding the that relative min. I'm gonna reduce it to 0 to 3.5. So let's go calc min 0 3.5. There we go. So our minimum velocity is -4, and it occurs at time 2.927. If you don't have to justify, then the min is a real nice little feature. Right?
This is Bryce.
Yes.
I heard about like the answers last night, and like for this one he put, or the person who did the answers put t equals 2.463, and so the minimum velocity was like when it was like closest to 0 or something. Like it's a different answer here.
We'll have to check it.
Okay.
That really is the minimum velocity,
Okay.
since this is your velocity graph. So we have to take a look and see what's up with that. Alright, so minimum velocity is, this is actually exactly -4, and it occurs at t equals around, what was it,
2.927.
927. Okay. Alright, this is the big one. So, we have x of 0 equals 2, we want x of 4. I'm going to do this one over here on the board. So, we're given x of 0 equals 2, and we want x of 4. We have velocity. We need an antiderivative at one point. How do we do this? We set up a definite integral with the limits being the values where we know it and we want it. So 0 to 4 of whatever the derivative is of what we want. If we want position, then right here goes velocity.
Is this the same way you set up and then you just take the integral of 0 to 4 that we found on the previous?
Very good. That's excellent. Okay. The antiderivative velocity is position, so it'd be x of t evaluated from 0 to 4, which is x of 4 minus x of 0. And now we're going to plug in and solve the equation. Hey, this is the integral from 0 to 4 velocity. Have we already found that somewhere?
Probably.
Where did we find it?
Back, it's displacement.
It's the displacement, right? So this right here, this is 7.753 roughly. And x of 4 is what we want. X of 0 is given, it's 2. So x of 4, you just add 2 to both sides, x of 4 is around 9.753. Does that make sense? Because you're going to need to know that. All right, the very last one. Find the average velocity from 0 to 4. I'm going to do that on this side. Hey, average velocity from 0 to 4. How do I set it up?
1 over 4.
Yeah, I'm going to use my average value formula, right?
One.
So I do 1 over 4 minus 0.
Times the integral of 0 to 4
Uh-huh.
of v of t.
Yeah, of whatever I want the average of. Right? So whenever I need an average value, I use my average value formula, and whatever goes in here is whatever you want the average of. Right? So if I want average velocity, that's what goes here.
1/4 times.
So this is just 1/4 times, hey, I found this already. Oh, look, it's 7.753. 53. By the way, if you're worried about rounding, because 7.753 divided by 4 could be off by the thousandth place, here's what you can do. If you, and I'm going to show you a little trick. So if we were to do this integral again, from 0 to 4, okay, so there's our integral, right, and there's the nice full number written out. If I need to divide this by 4, you know how on the main window you can just hit divided by and it'll pull the answer down? It does that from the graphing window as well. So if I just hit my division symbol right here, if I just hit divided by, it'll pull the answer from the graph window and just hit divide by 4 and it'll just do it. Right, so
Pretty much on point.
938. Was it the same either way?
Well, if you did it without it, it'd be 1.93825.
Oh, good. So it's still correct to the nearest thousand. All right, and that's that. Any
Okay.
questions on that? Yes.
Will they actually look like that close to the thousandth place? Like, will they actually like with that last
Oh,
decimal?
yeah. Every single decimal answer on the AP exam must be correct to the nearest thousandth unless the problem specifically says otherwise.
Okay.
Every answer. And you never assume, like even if the answer is people, don't round just because it's people. Unless they say round to the nearest whole number, you have to be correct to the nearest thousandth. And you know what? They don't say it anywhere near the problems. That is in the directions, like, you know, you get this booklet for the test, and there's like paragraphs of directions. It's in those paragraphs where it says, hey, by the way, all answers must be correct to the nearest thousand. So they will take off every time it's not. So you're losing a point every time if you don't. But there aren't that many round, you know, it'll come up maybe a few times in the free response. So, okay, any other questions on PVA from a calculator? What do you think?
Not bad.
Not bad?
Not bad.
Wait, we have to do the.
Wait, what is it?
Oh, okay. You know what? Here, I'll show you how to do it real quick. So our average velocity was around 1.938. By the way, what would the units be for this?
Meters per second.
Meters per second, whatever velocity is measured in. If we want to know the time where it reaches that, here's the quickest and easiest way to do it. So, and you know what? I want to get rid of this shading, right? Someone asked how to get rid of the shading. Quickest way to do it and keep your graph is to turn the graph off. If you arrow over to that equals, you'll turn it off, and then just turn it back on again. And that'll turn off the shading. So now I'll just regraph. But here's what we want. We want to know when the velocity equals 1.938. There's several ways to do this, but the quickest way is to just put 1.938 into y2, graph it, and then just find where they intersect, right? So you do, that's under your calc menu, it says intersect. And then it'll say which equations do you care about, right? Well, it defaults to y1 and y2, so you just hit enter on both. It wants a guess, and you do have to kind of arrow close to the one that you want so that it knows, because there's 3 of them. So there's our first one, is t equals 2.279.
We have to get all 3 of them for this times.
Yeah, but we're not gonna spend time on that right now. This is something that's rare, it's not on your test, it rarely comes up. Okay, any questions on that? Good. Alright, so now we're gonna switch to worksheet 2. I feel like we've spent plenty of time on Monday's test, but it's kind of important that we work on Friday's test as well. Worksheet 2 is pretty much like tomorrow's test in worksheet form. So if you can do worksheet 2, you are made in the shade for tomorrow's test.
Is that a real quote?
Not in the sun.
It's an expression. You
So
not
if
heard
you were
that?
to
Made in the shade, I've never heard that.
be in the sun, would you
Oh,
not be okay?
really?
Or like,
Yeah.
Ask your parents if they've ever heard it.
so tomorrow's the non-calculator and then Monday's
Oh, that's true.
Sorry, am I right? Am I
They
right?
might still have heard it though. I don't know. Do they say made in the shade in French? I guess it wouldn't
I
rhyme.
think they do. Fair dawn, be honest.
How do you say made in the shade in French? Eleanor, how do you say it?
Don't say it.
You don't?
It's
There's
just-
no way
it's
to
a
say
stupid
made in the
expression.
shade.
French people don't say things that are stupid.
Alright,
That's the big
okay. Here's what I want you guys to do. The first problem, can we just take the antiderivative of all 4 of these?
Yes.
No.
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 Split it up.
You've got to divide it all out, right? Get it so that there's no more quotient. I want you guys to see if you can do the setup for this. And then number 2 is a very nice straightforward U sub. I want you to do the setup for this as well. And see if you can rewrite the integral. And while you're doing that, I am going to hand back quizzes. And I think I'm going to pause the film, the video for a minute, so that it's not just sitting there recording a blank screen. So.